So my name is Nils Gerhardt. I'm the chairman of the board for GlobalPlatform. GlobalPlatform is a large industry organization that is securing everyone's life. So many people don't know what GlobalPlatform is about, and that GlobalPlatform provides the interoperability and the security that secures their everyday life when you look at, for instance, use cases such as a payment transaction using your credit card, or when you make a call with your mobile phone, or as another example, you connect an IoT device like your car securely to the internet. In fact, GlobalPlatform started with defining secure components. That's where everything started. A secure component could be a secure element or a trusted execution environment. In fact, it's a software-hardware combination that is specifically secured. So it provides a root of trust, and it's basically the trust anchor that you have when you build your device in, for instance, an IoT scenario. So we have deployed billions of these devices into the field as GlobalPlatform and with GlobalPlatform technology. We are extending this right now from secure elements and trusted execution environments to cover also embedded secure elements, integrated secure elements, as well as microcontrollers. And this is specifically important when it goes into the IoT field. IoT is really the strategy of GlobalPlatform going forward. This is where we need to be. And that's because IoT requires security. IoT is unique in the way that it actually affects us and the human life. So if you look at certain use cases, if you look at cars that talk to each other, that agree on which car goes first, or if you talk about use cases when you connect your home, where the lock is connected to the internet, or to any sort of network, and it's an electronic lock, or if you look at smart cities, where the smart grid is controlled using IoT, or another example, healthcare device that is operating on a patient, and that all needs to be secured. Otherwise, human life could be harmed. Now, it is not that easy to secure IoT because we have different aspects, like, for instance, the use cases that you look at. It could be a very simple device that is more or less a sensor. And on the other hand, you could have a car that gets connected, or an airplane, or a machine, industrial machine. And that, of course, requires different levels of security. While a simple device might only need integrity and an identity, some of the devices that are more complex, they actually need the full range of security. That includes confidentiality, availability, protection, and in some cases also non-repudiation and availability. So there are a lot of aspects on the security side that need to be tailored to the respective use case. So that's the first thing. The second thing why IoT and providing security for IoT is something special, and we cannot just use what we have today, is that we have an architecture that has a lot of billions of devices, in fact, at the edge, communicating data to the cloud, and they do that via the fog and gateways. And this structure actually needs to be end-to-end secured. So you start with these billion devices, you go to the fog and the gateways where you have 100,000s, and then you go to the cloud where you have thousands of clouds they connect to, and platforms, IoT platforms. And while the data flows from the device to the cloud, there's also data flowing from the cloud to the device when the device is managed. So that is something that's very unique and special when it comes to IoT. And then there is a third point, what makes IoT special and requires tailoring the security. That is when you look at how these devices communicate. So you have some devices that are using the latest and the greatest in communication technology, like 5G. If you look at 5G, you can use modern technologies such as software segmentation for the networks. You get priorities for certain services, let's say emergency services, for instance. You have certain security functionalities, low latency, and you have bandwidth as much as you need. But in other devices that are actually out in the field and that live on a battery, they communicate only from time to time, and their battery life has to last for 15 or more years. And you can't really run the same algorithm to authenticate and to do an update with these devices. If you were, you would halve the battery life or even drain it out. So, so that's the third aspect. You have to look into how the device is communicating and tailor the security to that specific device and use case. And that is something where we need to get the industry together to define the right level of security and the way we do security for IoT. So GlobalPlatform is in a very unique position to bring the industry together and to form this alliance, to specify what I was alluding to, different levels of security. And what we're aiming at, we try to provide a flexible way to and a more agile way on how we can actually apply security to the different use cases, which is much more suitable for an ecosystem like IoT, where the use case is at the forefront and the use case is changing and devices need to be updated and provide new functionality all the time. So we are trying to be agile here in some way and provide the right level of security guidance from the very start. So if you look at the architecture and how everything comes together in GlobalPlatform, we start with the security by design principle. That's the first start. And that means you, of course, have to design your software in a secure way and your architecture of the device, but it also refers to something that can be tested. So there's also a proposal that you have certain parameters in a device that allows you to later on test certain parameters. For instance, a measured boot or a random number generator or something like that. The next thing is that we add is the secure components. I already said that we have secure components like secure elements and trusted execution environments, microcontrollers we specify with security functionality. That is providing the so-called root of trust. The root of trust is the trust anchor for everything. But it's not enough, because that's only providing the root of trust. It's only as good as you use it later on. Then the next thing is you need to protect the device where the root of trust is in. And that is actually what we call the chain of trust. The chain of trust starts with measuring the boot sequence. So you start the firmware, the operating system, the application, and you're using the root of trust to secure this boot process and making sure that it's a controlled boot and that device starts in a secure state. But now you are at a state where you have this device booted up and ready to go for a specific use case, but it's not connected to the network yet. So the next step is you have to securely link it to a network and to a service. And how you do that is you have that device communicating a so-called device intent. That can be done, for instance, with a technology called MUD files. And that is a technology that allows that device, having, for instance, a URL coded into that device, and the onboarding party, when an enterprise uses that device, to check what this device needs from a network. This helps significantly in adding security, because it doesn't mean you have to open your network, but you can actually do network segmentation with these devices based on what the device really needs to communicate. So that's the next step. The third thing is you need to secure the onboarding. There are certain algorithms out there today, but I believe there needs to be some standardization and harmonization. If you look at different clouds today, there are different ways on how the onboarding actually happens. And that's the next step that need to be secured and agreed in the industry to provide this interoperability and the necessary security. And finally, that's not enough. Now it's on the network. So remember, we have the component that provides the root of trust. With a chain of trust, we protect the device, and we have the device in a secure state. We onboard it in a secure way using our IoTopia framework. And now we actually have to control the life cycle of that device. And that is important because with these myriads of devices out there, they will all have different states. And you have to manage that. For instance, with software inventory, you need to understand what software components are part of your devices to make sure that those are secure over the lifetime. Now you have everything that you need to secure the server end-to-end. And the final thing that we add on top from a global platform perspective is the certification and the compliance testing to make sure that we verify what the vendor has implemented is actually good security. So IoT is certainly the most important topic right now, but we actually are in a great situation to look at other technologies as well that are evolving. Such technologies include, for instance, 5G, but also machine learning, artificial intelligence, drones, robotics, all areas where you need certain levels of security. There's one area actually I forgot, and that is actually very important. It's quantum cryptography. Quantum cryptography is discussed out in the field right now, and the question is, how long does it take until some of the algorithms that we use today to protect the internet and what we do in our everyday life are not secure enough anymore, because quantum computers can crack these algorithms. So we are working actively in specifying what can be done and what can be used as the next generation of algorithms to keep the secure elements, components that we define, secure. And with that, Global Platform can base all the experience on 20 years of industry experience together with our members. I think we are going into a very bright future for a global platform. There is enough out there to specify to make sure it's interoperable and secure in the different fields, and I think we have the right member base to do that.